Now we're continuing our work on lesson 5, and we're actually looking at the experience of a negative a value. What's the experience of a negative a value? You can plug that into your calculator, so you can graph the original graph, and then you can graph the graph with a -3, and then we want to talk about the stretches and the reflections, because I actually have a stretch in here, but I also have a reflection. So that's why we want to make sure we take a look at that question. We want to deal with the stretch first and then the reflection. So I found a nice way to enter the question again. Uh, Try this on your calculator so I don't have to type it all in again. I made my y2 be equal to -3 y1, and I can actually make my calculator type y1 by doing the following. So go -3 and then hit your vars button. So -3 and then your vars button. Then we want to go to y vars. Vars standing for variables. And now I want function, which is number 1. Hit enter. And now I'll have the opportunity to type y1. So now I don't have to retype all of that. So now get that graph onto your scale. Please adjust your window. I've been trying to do that. So my x's go from -5 to 5, and my y's are actually -24 to 24. I'll fix that. Let's graph. So some of the points have taken interesting jumps. I'm going to track a couple of them. My 8 has gone down to -24. So my 8 is down here at -24, and my -4 has been hit with a -3. So it's actually up at 12. And then I have to connect the points, figuring out that the x-intercepts don't change. So those x-intercepts are the same. So I've got 3 x-intercepts to worry about. And remember, I'm going to take off those points there. So what is this graph doing? This graph is coming down from really high, going through -2, going through -24, coming back through the 12 points, and then back through the x-intercept. Let's draw. So right now I actually love my graphing calculator. I don't think I'd ever, say that. So how does the number 3 affect what happened? I have a vertical stretch. I stretched vertically. Vertical stretch of 3. But that -3 is technically a reflection. I'm now reflecting in the x-axis. So it was a vertical stretch of 3 about the x-axis. What happened to the x-intercepts of the graph? They didn't change. The x-intercepts are still the same. The y-intercepts certainly did change, and my maximums and minimums changed. So the y-intercepts plus my maximums and minimums changed by a factor of -3. Can I make that into a nice statement? Compared to the original graph, the graph of a times f at x, where a is less than 0, so a is negative, results in a vertical stretch. So we had that about the x-axis by a factor of a, together with a reflection in the x-axis. If you'd like to try out the language, there's a good summary on page 113. I'm actually going to go to page 114 and do some more examples with you. So off to page 114. Now remember, the policeman gives us some really nice notes. Make sure that you're understanding what the policeman says. Put that into your study sheet. So I'm going to try and do class example 1, 3, and 4. A horizontal stretch by a factor of 6 about the x-axis. Think about what that means. Horizontal stretch affects x, and what has to stay the same? The y has to stay the same. Vertical stretch by a factor of 1/5 about the x-axis. So x stays the same. Now my y is what gets altered. 1/5 times fx. So I have two more left here. A vertical stretch about the x-axis and a reflection. So a reflection in the x-axis means my y is going to change. So my y is going to become minus, and I have to have a vertical stretch by a factor of 3. So that's 3 times f at x. The x stays the same. I think I'm liking stretches now. A horizontal stretch about the y-axis by a factor of 1/2. So that leaves the x-axis, that leaves the y-axis alone, and then a vertical stretch. So the vertical stretch goes out in front. So that's y being vertically stretched by a factor of 1/4, which I can put directly in. But remember, the x's are always reciprocal. So when I have a horizontal stretch, I actually need to do the reciprocal of the stretch. So the reciprocal of 1/2 is 2. So I'm going to write down the equations and then see if you can figure out the stretches for class example 3. Now we need explanations. That 4x results in a horizontal stretch of 1/4 about the y-axis. Just working on some abbreviations. The next one is a vertical stretch. So that's a vertical stretch of 3 on the about the x-axis. And the last one has both stretches in it. It has a vertical stretch of 1/6 about the x-axis. So my vertical is 1/6 about the x-axis. And I have a horizontal stretch of 3. Remember, the horizontal always is reciprocal about the y-axis. Last example for this lesson, what's happening, I see that I've got a negative b value. So that's going to give me a horizontal stretch, but it's also going to give me a reflection because the sign has changed. So I have a horizontal stretch of 1/2, which is going to affect my graph about the y-axis. And then I've got a reflection. Now I've got a reflection that is showing my x becomes minus x, which identifies my mirror as y. So my mirror is going to be equal to the y-axis. So first I'm going to stretch and then I'm going to reflect. See if you can find those points. Compare them if you want to your answer book. I'll try and get them graphed. So how would you build this graph? I would build this graph with the skill we have of making a table of values. So I've created a table of values reading the graph left to right. So I had minus 6 comma 0 I have -4, 2. I have 0, 5. I have 4, 5. I have 5, 0. And I have 6, -4. These are all the XY points of my original graph. And what I understand with this graph is that my X values are going to get hit by a factor of 1/2 and negative. So my X values are going to be hit by a factor of, take the X values and times them by -1/2. So when I plot the graph, I'm going to get -6. -6 times 1/2 is 3. And it's going to be at that same Y value, 3, 0. -4 times 1/2 is 2. So 2 is going to be up at 2. So that's right here. 0 times 1/2 is 0. And 5, that's going to be there. 4 times -1/2 is -2. So that's over here, -2, 5. 5 times -1/2 is -2.5 and 0. And 6 times -1/2 is 3. And 3 is down here at -4. So connect those points, see how they compare to the answer. That completes lesson 5. Please consult your pink sheet for the assignment. And if we have time today, feel free to take a look at lesson 6. It's going to put all of this work in an application format, but we'll take some time on Thursday's class to play with a question or two, some work time, and then towards the end of Thursday's class, we'll actually have a quiz on lesson 5 and 6. So the target is to still learn the material, but we'll just spread it out a little bit. So the quiz coming at the end of Thursday's class. Thank you.